our electrolysis, right? So what exactly is electrolysis, or what are we talking about when we're dealing with electrolysis? So electrolysis is basically, let's say you have a compound. So first things first, electrolysis is always of an ionic compound. Okay, we can't do it of a covalent compound, and the reason being is because you are breaking it down into ions. You are using charges, right? We're using a positive charge and a negative charge. We're using electricity to pull the compound apart. Now, because we're using charges, so it has to be an ionic compound. In a covalent compound, you don't have any charges, right? There are no charges in a covalent compound. So that is why when you do electrolysis, it has to be an ionic compound. That's like rule number one. Okay. The second rule of electrolysis is that it has to either be molten or in a solution. I mean, you either need to melt it. So for example, I have sodium chloride, right? So in solid state, I have like big chunk of sodium chloride. So I will either need to, melt it in a furnace, bring it into a molten state, or I will need to mix it in water or something else and make a solution. If you take a solid compound, you take any solid compound, potassium chloride, magnesium fluoride, any solid compound, and you try to do electrolysis, it's not going to work because it is solid. It needs to be in a molten or in a liquid state so that the ions are free to move. That's the major thing, because what you and I are doing is we're using electricity to separate them. We're using electricity to break the compound down. We're using electricity to break our ionic compound into two. So because we're trying to break down the ionic compound, the ions have to be free to move, right? If they're in a solid state, they are going to, just be held together tightly. They're just going to be fixed in their position. They're not free to move. So that is why they need to be in a molten or a liquid or a solution state so that the ions are free to move and we can perform the process of electrolysis. That making sense?
Yes.
Okay, so that is why, based on the explanation, we can have the definition of electrolysis, that electrolysis is the breakdown of an ionic compound, which is either molten or in solution, by passing electricity through it. So by using electricity, you're breaking down an ionic compound, and the state has to be molten or liquid. Now, the substance which we are breaking, so for example, sodium chloride, that's what we're breaking. The substance that we're trying to break, that is known as electrolyte, or the solution or the molten substance we're using, that will be known as electrolyte. Okay, and what is an electrolyte? If they ask you like a definition, so an electrolyte is simply a substance that can conduct electricity when it is liquid or in a solution. So any substance that can conduct electricity in a liquid or molten state, that substance is automatically going to be known as an electrolyte. Now, substances that cannot conduct electricity, like your compounds that are, going to be like your compounds that are covalently bonded, for example, those substances that cannot conduct electricity, we call them non-electrolytes. And then we have certain substances that can conduct electricity, but like a little bit, not too much of it. They'll conduct like a little bit of electricity. So we call them weak electrolytes, but that is generally not something that you're going to deal with in this particular topic. We are specifically dealing only with electrolytes. Okay, now when we talk about electrolysis, what is necessary, right? What equipment do we necessarily need? So the thing that we need is that you, of course, need to have an electrolyte, the solution or the molten compound that you want to separate, right? Whichever compound you want to break down, you need to have that. So that will be your electrolyte. Another thing that you need is, of course, you have a battery. right? Because you're using electricity. It's in the name, electrolysis. So you need to have some source of electrical power. And that source of electrical power is going to be a battery. So we have a battery, and that battery is going to be connected to what we call electrode. So electrodes are simply the substance that will allow the electric current to enter or leave the electrolyte. So this electrical current, the battery is generating it, right? This electrical current is flowing through your wires. After it throws your wires, you need to have something that will allow this electrical current to enter into our solution. And this is where the electrodes come in. So the electrodes will allow the electrical current to pass through into the solution so that we can perform the process of electrolysis. When we talk about electrodes, electrodes generally have to be made of a material that's non-reactive. If we use a material that's just going to react with our electrolyte, that will just react with our solution, that's just going to ruin the process for us. We're not going to get accurate results. So we want to use material for the electrodes that is non-reactive, that is not going to interfere in what you and I are trying to do. And that is why the material we normally use is either carbon, because carbon is pretty non-reactive, and the other one is platinum. So platinum is like extremely non-reactive, but platinum of course is more expensive. Graphite is generally most of the time non-reactive, and it is a cheaper option as well. So majority of the time you are in your past paper questions, you are going to be dealing with a carbon electrode or graphite. If they say graphite and carbon are the same thing, right? Graphite is just one of the forms of carbon. So graphite and carbon are the same thing. So if you write down graphite or carbon in your past papers, it's like completely correct. So either platinum or carbon, and they have to be completely non-reactive. Do you follow me so far?
Yes, but I have a question.
Yes, go on.
What if we use elements from the last periodic table, the noble gases, in their solid state though?
No, can you say it again? Sorry.
Yeah, okay. What if we use like the noble gases, but instead of using them in their gas state, we use them in their solid state as electrodes because they're
The material also needs to have the ability to conduct electricity, right? You can't just go ahead and use any substance that is non-reactive. It needs to be a substance that is non-reactive and able to conduct electricity. So that really limits out the option. The only if you look at your periodic table, metals are able to conduct electricity and graphite can conduct electricity. In the metals, generally, platinum is very non-reactive. That is why we're using it. If you take a noble gas, first of all, and if you manage to compress it, so first of all, you need a lot of equipment and you need a different temperature and significantly high pressure to turn it into solid. Let's say you turn it into solid, they will not conduct electricity because they do not have any free electrons, right? You might have studied this, that metals can conduct electricity because they have free electrons. When you and I will do the topic of bonding, I will explain to you why graphite is able to conduct electricity. I will tell you. But the primary reason is because they all have free electrons that are able to conduct electricity. When you talk about noble gases, first of all, turning them into solid state is going to require, is going to be significantly much more expensive and is going to require equipment. And if you turn them into solid state, they don't have any free electrons. They cannot conduct electricity. So the electrical current will not be able to pass on from the battery to the solution. Does that answer your question?
Yes. Thank you.
So it's not just about them being non-reactive. It's about them also being able to conduct electricity and be non-reactive at the same time. Okay. So when we talk about our cathode, okay, so when we talk about our electrodes, so there are two types of electrodes, okay? So electrodes, when you're going to talk about, one is going to be the positive electrode and one is going to be the negative electrode. How can we determine that? We look at the battery. So when you do physics and you do the topic of electricity and physics, if you're doing physics, I'm sure you are going to learn this. The big end of the battery is usually positive and the smaller end of the battery is negative. Okay, so the electrode that is connected to the positive side, we call it anode. We say this is the positive electrode. Why? Because it is connected to the positive side of the battery or positive terminal of the battery. This one that is connected to the negative terminal of the battery, we call it cathode, or you can say this is the negative electrode. Okay, now this is the way we name that. So the one that is going to be attached to the negative side, it's going to be negative cathode, and the one that is attached to the positive side, that is going to be your anode. Now, when we talk, this is just how you're naming the electrons. When you talk about ions, when I'm talking about ions, it's the opposite. Okay, when I'm talking about ions, it is the opposite. Positive ions are known as cations. Negative ions are known as anions. So electrode, the naming is different. When you're naming ions, the naming is different. In electrodes, positive one is the anode. In ions, the positive one is the cation. In electrodes, the negative electrode is called cathode. But in ions, the negative ion is known as anion. So for example, sodium chloride. Sodium is the cation and chlorine will be the anion because chlorine is negative and sodium is positive. You got this part?
Yes, I think I actually know why they're called that. Isn't it because they attract the opposite charge?
Yeah, exactly. They attract the opposite charge. So what's going to happen is that the positive charge, that are the cations, they will go to the cathode. So the positive ones will go towards the cathode, and the anions that have the negative charge, they will go towards the anode. That is why they have been named in such a way, right? So negative ions are anions and they will go to the anode, which is the positive one, because opposite charges are going to attract each other. So positive cations are going to go to the negative cathode and negative anions are going to go to the positive anode. So this is what basics of electrolysis that you need to know. So if everything is okay, let's move on, right? Nothing to ask.
No.
Okay. Now let's actually start with the electrolysis. So when we talk about electrolysis, let me tell you, I'll tell you how you can solve questions related to it. Now, when you have got electrolysis that have only two ions, it is really simple. It's going to get more complicated when we talk about multiple ions, when you've got four ions. That is when it gets a bit complicated, but generally speaking, you have your lead bromide. Okay, so lead bromide is in molten state. Whenever you're going to have molten state, we only have two ions because you have just taken your compound and you have just molten it. When you take a compound and you mix it in a water and you make a solution out of it, then you have got multiple ions because now water is mixed inside of it. So you need to consider water as well. I will explain that particular part when we get to it. But right now I'm going to tell you how we're going to do electrolysis of molten compounds. So molten compounds, this is going to be pretty simple. Molten compounds, you only have two ions. For example, we're dealing with lead bromide. So we will have two ions. One ion that we're going to have is going to be lead, and the other one is going to be bromine. Now, before we continue, do you know why we have this 2 written in the bracket?
Because lead's charge is -2. It needs two atoms.
Yeah, okay. Okay, so basically, just give me 1 second. basically, so you and I need to go over the topic of periodic table. So in periodic table, you have got certain compounds, certain elements whose charges are fixed. Okay, and I will explain this to you. But generally speaking, for example, group 1 always has a charge of +1. Group 2 always has a charge of +2. So in group 2, we have a group of compounds that are known as transition elements. Have you heard of them?
Yes.
Yeah. So when you talk about transition elements, they have multiple charges. They can be +1, +2, +3, +4. So because they have multiple charges, so whenever we're going to be dealing with a transition element, or even you, whenever you're writing down answers in your exam, so in a transition element, we always mention the charge in bracket because the charge can be anything, like it can have different charges. So that is why we need to specify that we are talking about this charge. So for example, iron can be +2 or +3. So you need to say iron 2, iron 3. So this bracket is specifically for transition elements, and it's to specify that in this compound, it was this charge. So the 2 automatically gives you an idea that it's going to be lead 2+. Okay, so what is going to happen is that you are now going to do your electrolysis. When you're going to do your electrolysis, there are 2 compounds. You have your lead ion and you have your bromine ion. Now, the bromine ion is going to be attracted towards which electron?
The cathode.
Towards the cathode. Are you sure?
Wait, no. Hold on a second. 1 second. Isn't the bromine here negative?
Yeah, it is negative, right? It's negative, so it's going to be attracted towards the positive electrode.
Anode.
What is the positive electrode called?
Anode. Cathode. Anode.
Anode. Yeah, you're right. It's called an anode. So the bromine is going to go towards the anode. And when we talk about the lead, where is that going to go?
To the cathode.
To the cathode. Exactly. Good job. So what is going to happen is this. This is your anode. You can see it's connected to the positive terminal. And you can see that the bromine can be seen in the form of brown vapor or brown gas, right? So bromine, you can see it collecting around the anode. You can see it depositing around the anode, and you can see it in the form of vapor. You'll see brown colored vapors. As for the lead is going to go towards the cathode, that is the negative electrode, and you will see it collecting around it. You will see the lead just, collecting around and gathering around it, the cathode. So this is what you are going to observe. Now, this was all simple so far. What we have to talk about is our equations. So these are known as half equations, what you see over here. And half equations is basically what is happening at the cathode and at the anode. So I automatically said to you that the lead is going to go towards the cathode. I just straight away told you, right? I said it's positive, it's going to go towards the negative, and it's at the cathode. Now you're going to say, okay, fine, it's at the cathode, but so what? I mean, it went to the cathode, it was attracted towards the negative side, fine, but what happened after it got there? What basically happened? So what happens is a process that we know as reduction. What is reduction? Reduction is basically where the ion gains electrons. Okay, let me explain this. When we are talking about any positive ion, the reason that ion is positive is because it has less electrons. For example, let's take sodium. If a sodium is neutral without any charge, it will have 11 protons and it will have 11 electrons. Now, let's take the sodium, but with a charge of +1. So if it has a charge of +1, it has 11 protons, but only 10 electrons. So for any positive charge, the numbers of electrons have to be less. And if this sodium ion wants to turn back, if it wants to turn back from an ion into an atom, it needs to gain that electron back. It needs to somehow get that electron back. And it needs to take that electron back so it can go from an ion back towards the atom state. So when any ion gains electrons, when it takes electrons or it gains electrons from anywhere at all, we call it reduction. So for example, if this sodium ion manages to gain an electron and become a sodium atom, we will say sodium has been reduced or sodium has undergone reduction. Any confusion in this part?
No.
Okay, so this is what happens at the cathode. By the way, reduction has multiple definitions, but when we come to the topic, I will go over this with you. So reduction is what happens at the cathode. So what actually is happening? You know the cathode has a negative charge, right? It's the negative terminal, which means it has a lot of electrons. So what happens when this lead ion will reach the cathode, there is an abundance of electrons. And this lead ion will be able to go, or it's able to take the 2 electrons from the cathode and it can turn into an atom. So the lead ion can turn into a lead atom, lead metal. And when it's going to turn into an atom, it's going to turn into a metal, you will be able to see it collecting around the cathode. So when it is in a solution form, you and I can't observe it because it's in a solution. It's mixed, it's made an ionic bond. It's present in the form of ions. But when it turns into an atom and it starts collecting around the cathode, you and I can visualize it. And this equation that I have written down, this equation is known as half equation, and you are going to be expected to write them down for process of electrolysis in nearly all of your past paper questions on this topic. So this is, generally speaking, for cathode. Whenever any positive ion is going to cathode, what is the process that will happen? Reduction. What is reduction? Gain of electrons. Exactly. So all you have to do, cathode equations are pretty easy to write down, right? The anode ones still get confusing, but the cathode ones are really easy. How are they easy? They're easy in this way that you will always write down the ion. You will write down plus and then the number of electrons. So if the charge is 2 plus, then you need 2 electrons. If it's plus 1, then you just need 1 electron. If it's plus 3, then you will write down 3 electrons. So you just write down your positive ion. You write down electrons in front of it. You say plus following number of electrons, and you put an arrow and you write down the atom. So generally speaking, for your cathode equations are pretty easy. The equations become a bit complicated when you're dealing with the anode, and let me explain this to you. So at the cathode, the process that was happening was known as reduction. At the anode, you have an opposite process. You have the opposite process, and that is known as oxidation. What is oxidation? Loss of electrons. Loss of electrons is known as oxidation. So when you were gaining electrons, that was reduction. When you're losing electrons, that is oxidation. Let me explain this with another example. Let's take chlorine. Right? So chlorine, it has a charge of -1. Now, when chlorine has a charge of -1, that is because it has more electrons than protons. Whatever protons it has more electrons than that. Just 1 second. So chlorine has 17. Okay. So when it will get a charge of -1, the number of electrons will go from 17 to 18 because it has gained an electron. That's why it has a charge of -1, because it has one more electron than before. So it's -1. Now, what is going to happen is this, that if this chlorine wants to return back to 17, if it wants to return back to an atom, if it wants to go back from an ion to an atom, it needs to lose that electron. It has to get rid of that electron so it can go back to being an atom. This is going to be known as oxidation. When a negative ion will lose electrons, we are going to say that is oxidation. And the same thing will happen to this bromine. So we said bromine is the one that is going to go towards the anode. So what is going to happen? This is your bromine ion. Your bromine ion has to lose an electron to become bromine atom. Now, this is the simple basic equation that you can write down. But the way this gets complicated in an anode is that we don't write down electrons with a negative sign. There is no specific reason for that. It is a standard. We always want to write down plus electrons. We never want to write down minus electron, right? It is a standard. That is the way we have standardized it. We have fixed it. We want to write electrons with a positive. So right now our equation makes sense. The bromine ion will go towards the positive anode. It is positive, which means it has less electrons. So the bromine will give up its electron. It will say, here, take one of my electrons, and it will turn into the bromine atom. So everything checks so far. But when you are writing the equation, so when you're writing your equations in your exam, you can go ahead and you can always first write it down like this with a piece of pencil, or just like as your initial equation. And then you need to do a little bit of mathematics, right? So what you will do is you'll move the electron to the other side of the equation. So your equation is going to become Br minus 1 gives us Br plus 1 electron. This is how you're going to write it down, because we always want to write down electron with a positive sign. So when you are writing in your past papers, in your exams, your finite equation, you will always take the electron on the other side and say, this is my actual half equation for the anode. And to complete it, you just need to do balancing. So bromine is in group 7. And group 7, they are all diatomic. What do I mean by diatomic? Cl2, F2, I2, Br2. They are always going to be present in a diatomic state. That means that they're always going to be present with 2 atoms, right? So you will have 2 atoms of fluorine always bonded to each other. Don't worry about this detail. When I do periodic table, I'll go into great details with this with you. But generally speaking, the formula for bromine is Br2. So this will be Br2, and to balance it out, we will have to put a 2 over here and a 2 over here. So this would be your final half equation for the anode. Is this making sense?
Yes, but wouldn't we have to reduce 2 electrons?
In the anode, so in the anode, you are not doing reduction. In the anode, you're doing oxidation, right? So in the cathode, you were doing reduction, which is why you were writing down the plus 2e. At the anode, you are doing opposite. You are doing oxidation. So basically, actually, in reality, what is happening, your bromine ion, please note that it's an ion, is losing 1 electron to turn into an atom. So that is what is actually really happening. But that's not what you and I are going to write down. We always want to put electron as positive. So that is why we are writing down electron on the other side of the equation. Okay, so when you're talking about this is not going to be reduction. Why? Reduction is when an ion loses electron. So when an ion gains electron, that is reduction, right? When an ion is gaining electron. Over here, the positive sign is not with the ion. The positive sign is with the atom. So that is why even though I've written plus, this is not reduction because I've written plus on the other side. I have written plus on the side of bromine atom, not on the side of ion. If I write down plus with the ion, then it is reduction because ion is the one that is losing and gaining electrons. So if ion gains electrons, it is reduction. If ion loses electrons, it is oxidation. So at the cathode, always, 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 it is reduction. At the anode, always, 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 it is oxidation. At the cathode, you will write down plus electrons with your ions, whatever your ion is, plus electrons on the same side. On the anode, you will always write down plus electrons on the other side, away from the ion. Wherever your atom is, you will write it down over there. Is this clearing up the confusion? Is this getting too confusing?
No, I understand it, but like the charge for bromine in general is -1, right?
Sorry, I couldn't hear you.
The charge for bromine in general is -1.
Yeah, it's negative. Yeah, the reason for that is because the formula of bromine atom is Br2. That is the reason we were adding the 2 to 2, because the formula for bromine is Br2. Bromine atom. When you talk about bromine atom, bromine is not present as a single atom. Bromine is always present as two atoms that are joined together.
Yes.
That's the formula of it. So that is why we want to balance it, right? If we want to make Br2, we need two ions. We need two ions, so we need two electrons. So that is just simple balancing. That's it.
Yeah, no, I'm asking about the charge on top. The one on top of the
the charge on bromine
-1.
is, yeah, it's -1. Yeah.
Shouldn't it change to -2 as well because we have two bromine atoms?
No, it is not going to become -2. This will stay -1. The charge will stay the same. The charge does not have anything to do with the balancing, right? The charge has to do with the number of protons and number of electrons. They are fixed. Charge is always fixed. It has nothing to do with any of your balancing. The reason we're writing down 2 electrons is because we're taking 2 ions. So one bromine ion will, use 1 electron, and the other bromine ion will use the other electron. So you're going to end up with Br2. That is basically all that's happening. But your charge always, always in any equation, not just this electrolysis topic, any equation, charges are fixed. Charges do not change. Your balancing will change, but your charges will never change. Okay? So the charge for
regardless of the number of the sorry, 1 second.
Can you repeat?
Yeah, I was just saying, regardless of the number of the amount of the element you have, the charge is not going to change.
Charge is fixed. Charge is always going to be fixed regardless of any balancing, regardless of how much you have it, regardless of whatever number is written next to it, charge is fixed.
All right. Yeah.
Okay. Fine. So this is what we know about our lead bromide. Okay. Now, taking the same concept, and by the way, this is a really a lot of new information. So at any point you feel like you are getting a bit too saturated with the new information, just like stop me. Okay. So next electrolysis that we are going to be discussing is aluminium oxide. This is the formula for it, by the way, Al2O3, aluminium oxide. And when we are talking about aluminium oxide, so the basic principle, reduction, oxidation, it's the same. But aluminium oxide is slightly at a higher level than lead bromide. So what I will do is I will give you the extra information. But when it comes to making the equations, you and I will do that together. So we get the practice of making the equations. So let's talk about aluminum oxide. Okay. Now, aluminum oxide is not present in a pure form, right? For example, if you go mining, if you go into the mines, you're not just going to find aluminum oxide lying there and you can pick it up and do your job. No, aluminum oxide is going to be present in the form of an ore. O-R-E, ore. What is ore? Ore is when you have a metal and it is mixed with other compounds. So you have this metal and it's going to have different, compounds, different impurities mixed inside of it. So we call it ore. The ore of aluminium, it has a special name. So later on, when you and I do the topic of metals, we'll discuss that different metals have different ores. So the ore for aluminium, we call it bauxite. That's the name for it. It's just a simple naming, right? So you have got this aluminium oxide. It's present in an ore. The name of the ore is bauxite. And like I said, in the ore, you have your metal and then you have impurities. So you've got impurities such as iron, sand, blah, 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 blah. So first of all, you have obtained your bauxite. It is with you right now in your hands. Now you are like, okay, before I can do anything, I need to get rid of all the like impurities, the iron, the sand, all the extra stuff. I just need to get rid of it and I need to get my hand on some pure aluminium oxide, like without any other thing mixed into it. So what you do is you treat it with sodium hydroxide, NaOH. This is an alkali. Okay, so you don't need to go into details of it. You'll take your sodium hydroxide, you'll do the treatment, whatever it is, and you'll end up getting pure aluminium oxide. Let me specify, we don't have aluminium. We still have a compound. We still have aluminium oxide, but we got rid of stuff like dirt, sand, blah, 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 blah. So now we have pure aluminium oxide. Now, you'll say, I'm going to go ahead and I'm going to start the electrolysis and I will separate aluminium and I will take away oxygen and I'll get all this pure aluminium and, I'm just going to run my business with it. But you have another problem. So the first problem you cleared. You got rid of the impurities. You got your hand on some pure aluminium oxide. Problem number 2. Aluminium oxide has a really high melting point. It has a really high working temperature. That's the term we often use for it. Working temperature. So it has like a really high working temperature. You are running your factory and you're trying to melt all of it, because remember, electrolysis is not in a solid state, it's in molten state. So you need to melt all of it, right? But you're just trying to melt it, and the amount of temperature you have to give is like so high that you're just like, you're like, this is so expensive. You give such a high temperature, I have to, burn so much fuel. It's getting so costly for me. How am I supposed to do this? So what did the scientists do? They found a mineral. The name of the mineral is cryolite. C-R-Y-O-L-I-T-E, cryolite. Now, what they did is they took this mineral cryolite and they mixed it in the aluminium oxide. What did the cryolite do? It lowered the working temperature. It brought the working temperature down, so you needed less energy to melt it, less temperature to melt it, so it was more cost effective. You're like, okay, fine. I'm going to take my cryolite, I'm going to add it to my aluminium oxide, and now I need a lower temperature, so now this is less expensive for me. So what you're going to do is step number 1, purify it, right? Get your hand on some pure aluminium oxide. Step number 2, add cryolite to it. Get the working temperature down, and then you melt all of it until you have molten aluminium oxide. Any questions so far?
No. But wouldn't that mess up with the results of the aluminum oxide because it's not pure aluminum oxide?
Right. So when you talk about the purity, so you're right, it is going to become impure. But the good thing about cryolite is that it does not interfere in our electrolysis. When you talk about the impurities that are present in your ore, remember when we had the ore, I said it was impure. Those impurities interfere in the electrolysis. So we don't want them. But when we talk about cryolite, it's not going to interfere in our electrolysis. It's not going to affect our procedure. That is why we are adding it, because the even though it is making our aluminum oxide impure, you are adding an impurity to it, but the impurity is not really affecting our procedure. So but it's not affecting the procedure, and it's also lowering the melting point. So that's like two good things. It's lowering the melting point, and it is not interfering in the procedure. So that is why we use very specific one, use cryolite. We don't use anything randomly to do it. We use cryolite because it is not interfering in the procedure. Any other impurity would interfere in the procedure, and that would affect our results. So you are right, it is an impurity, it's not pure anymore, but it's not affecting in the procedure. And on the other hand, it is actually helping us by lowering the temperature. So that is why we're adding it. Does that answer your question?
Yes, it does.
Okay. Now let's go on to the actual electrolysis. Now the cell for aluminium oxide electrolysis looks different, but it's the same thing. Whatever concept you and I have covered, it's the exact same concept. The only difference is that it just looks a bit different. How does it look a bit different? I'll just show it to you. So and all of these are your anodes. If you remember, anodes are the positive terminals. All of these are your anodes, and your cathode is actually over here. This is your cathode. This, right? This is your cathode, and your anodes are over here in the middle. Okay. So what happens is this, that you have your solution of aluminium oxide and cryolite all around it. The oxygen is going to, so this is what the cell actually looks like. Now, so it's the same concept. We're not doing anything different. It just looks different. That's it. Now, what you and I need to discuss is the actual process of electrolysis. So let's go ahead and look at our ions. This is our compound, aluminium oxide. You will have two ions because this is molten, right? Remember, in molten, we only have two ions. So we will have aluminium ion and we will have oxygen ion. Now, can you tell me what will go to the cathode and what will go to the anode?
Okay, so the aluminum will go to the cathode and then the oxygen will go to the anode.
Exactly, completely correct. Now let's try to make the half equations. So the half equations are not different. There's nothing different about it. We're going to make them exactly the way we made them before. Now, can you tell me what process takes place on the cathode?
Yes, 1 second though. In the cathode, isn't it reduction?
It is reduction. Good job. And what is reduction?
Gain of electrons.
Gain of electrons. So when I'm writing my equation, I'm going to go ahead and I'm going to start writing it by first writing down my ion. My ion is aluminium 3 plus. It is gaining electrons, right?
Yes. It's gaining
so I will write down what? What will I write down next?
Plus 3 electrons.
Plus 3 electrons. Good job. And what will I get?
Al.
Al. Good job. So this is the half equation at the cathode. So all of your aluminium will just collect over here at the bottom. And then you can simply go ahead and remove it all out. Now, let's look at the anode. What process takes place at the anode?
Oxidation, which is loss of
Ox-
electrons.
Exactly, good job. That is loss of electrons. So if I'm writing down my equation, I'm going to start with the charge of oxygen is 2 minus. I'll start by writing down the ion, and then what will I write?
Can I actually give you the last result?
Sorry,
Can I give you the result immediately?
the result
Yeah.
of what? Of the electrolysis?
Yeah, the result of the formula.
Oh, I don't understand what you're asking me. Sorry.
Okay, it's all right. It's all right.
No, no,
So
go ahead. Ask.
basically-
Like, I don't understand. That's like explain.
No, it's fine. It's fine. It's
Are you
gonna.
sure?
Yes, I'm sure. It's going to be zero. Sorry, I meant oxygen, which is -2, negative
Yeah.
electrons, and it will give out O2. So we'll
Yeah.
have to balance it out firstly. So 2O, 2O -2
Yes.
gives
Good
out
job.
O2 plus 2E.
O2 plus. Okay, this will become 4. The reason it will become 4 is because one oxygen is losing 2 electrons. So 2 oxygen will lose 4 electrons.
Oh, yes.
Okay. Yeah. So when you're balancing it, you have to multiply the number of electrons as well, right? Good job. You're perfectly correct. This is going to be your final equation, half equation at the anode. So the oxygen is going to be seen in the form of bubbles because it's a gas. So you'll see the oxygen bubbling around the anode. You will see the aluminium collecting at the bottom at the cathode, and this is the half equation for the cathode, and this is the half equation for the anode. Final thing that I want to add about our aluminium. In the electrolysis of aluminium, we have a slight problem. And the problem is that when you talk about the anode has to be changed regularly. We have to keep on replacing the anode. What is the reason for that? The reason for that is that the carbon, because we're using graphite anodes, so the carbon of the anode reacts with the oxygen. So at the anode, we were producing oxygen gas, right? So what happens is that the carbon of the anode starts to react with the oxygen and it starts to produce carbon dioxide. Because the graphite, or because the anode starts to react with the oxygen, it starts to wear off. That's what you're going to go ahead and write down. It starts to wear off, and because it starts to wear off or it gets used up, so you need to regularly replace it. You need to replace it as soon as you can. In fact, not as soon as you can, but you need to keep on replacing it because the graphite reacts with the oxygen, and that is why the anode, they keep on decreasing in size because the reaction is taking place. So you need to keep on replacing it regularly. So you will see questions when you're doing your past papers related to it. You're going to get questions on the cryolite. Why are you needing to add cryolite to it? We're going to get lots of questions on that. You are going to get questions on why do the anodes need to be replaced, and then of course they're going to go ahead and ask you to make your half equations for both the cathode as well as the anode. Got it? Any confusion in this?
No, I got
Okay.
it. Thank you.
Okay, so that is what you need to know about your molten compounds. Now, after that, we need to move on to our solution. Okay, so these were molten compounds. You only have 2 ions. In a solution, what happens? You are now including water. So now the ions of water are also a part of the electrolysis. So now it's not that simple anymore. But I don't want to start with the the solution part right now. I don't want to get into it right now. I want to get into it when we are like in a random class. So right now what I'm going to do is that I am going to do a couple of questions with you related to your general electrolysis and what we have studied so far. Okay.
Okay. Yeah.
Okay, just give me 1 second. I'll share my screen with you. So let's go ahead and take a look at this particular question. So this is the kind of questions you're going to see related to aluminium. Go ahead, give it a read, and let me know the answer to part 1, whatever you think the answer is.
Because it has a really high boiling point, working point.
Okay, I'll just say, do take a look at the question again. They're not asking what you think they're asking. Just take one look. If you don't get what I mean, let me know. I'll give you a hint.
Oh, is it because solid aluminium doesn't have enough
Yeah.
electrons to carry the
Yeah.
electricity?
Okay.
It doesn't
You're
conduct electricity.
you're thinking along the right track. You just need to be more careful with your words. What words you're using are going to make you lose marks. The reason for that is that and this is a general answer you can use for other questions of this type, in solid state, there are no free ions. Your wording is important, right? So free electrons is what we say when we talk about metal and non-metal. So in metals, we have electrons. In an ionic compound, the electrons are not free. The electrons are inside the atom, but the ion is free. The atom itself is free. The ion itself is free. So it is able to move around and conduct electricity. You will use the term free electrons for metals. For an ionic compound, you use the term ion. So you will say in solid state, there are no free ions to move about, hence it cannot conduct electricity. Right? So how you say it doesn't matter. The thing that they want to hear, no free ions. That's what they want you to say. You're saying no free ions, they are happy with you. So it's in your Cambridge exams, it's very important that you say the thing that they want to hear, because what you say before it, after it, or how you phrase it is completely up to you, but you have to be correct with your words. No free ions, no free electrons is a chance, then that is up to the examiner's discretion, right? If they're in a lenient mood, they might just give you the mark. If they're not, they'll like deduct it. So what we're trying to do is we're not trying to give them any chance to deduct our marks. So we want to give them the kind of answer that, even if they are not in the mood, they still have to give you the marks for it. So no free ions, that's what you say. Okay, now the second one is what we were talking about. So go ahead, just answer that one.
Because cryolite lowers the aluminum's working point.
Exactly. So what you're going to say is that the working temperature of pure aluminum oxide is too high. So molten cryolite reduces the working temperature of the aluminum oxide, quite simply put. Okay. Now take a look at part 3.
They need to be replaced periodically because the carbon and because the carbon reacts with the oxygen and produce CO2, which will then wear off. So they'll need to replace.
Good job. So the carbon anodes, they react with the oxygen. So the carbon anodes get worn off or they get used up. So we need to replace them periodically. Okay. What about part 4?
And because it's unreactive.
Yeah, good job. It is non-reactive, and another reason you can possibly give is that it is cheap. Okay, let me see if we have another. Okay, go ahead, take a look at this one. You can take a look at part A, 1 and 2. 3 is not for you.
Okay, so we'll have oxygen and
Yeah.
4 electrons.
Electrons are not a product. Electrons are just a part of the reaction. They are what is happening at the atomic level. They are not a product. What is another product that is produced? You do know it, but you just know it as an answer to a different question. I'll tell you that.
I think it's not cryolite, right? Because cryolite doesn't interfere with
cryolite has no role in it.
Yeah, so it's oxygen and carbon, the carbon dioxide.
Exactly. So you know it as the answer to why graphite anodes have to be changed, but like they mixed it up and they added it over here, that which two products are formed, so it's carbon dioxide. Good job. Okay. Take a look at part 2.
Okay, firstly, it must contain cryolite because cryolite lowers the aluminum's working temperature. And secondly, because wait, hold on, I need to think about the second reason.
Yeah, go on. If you
Does it by any chance remove impurities? It doesn't.
Sorry?
I said, does it by any chance remove impurities? But it doesn't because
no, it does not impure. It simply, okay. So another reason you can give is that it improves conductivity. I mean, it improves the conduction, electrical conduction, or you can say it acts as a solvent, right? Because you are dissolving the aluminum inside it. So it is acting as a solvent for the aluminum. So you can either say that, it acts as a solvent, or you can say it improves the conductivity. Okay. Take a look at part 3. I don't expect you try to answer it. I don't expect you to answer it, but I'll just go ahead and explain to you the reasoning behind it because it's related to this topic. This is actually, this part 3 is more related to the topic of acids and bases, but I don't know if I'll remember to tell it to you then. So I just want to give you at least the bit of a concept right now. So if you get questions like this, you know how to answer them.
Okay, just give me a second.
Yeah, just read the question, right? Have you read the question?
Yes, but I just want to check something.
Yeah, go on.
So I just wanted to check the iron oxide. 1 second. Okay, so I think it's because NOH is an alkali,
Yeah, good job.
so it will attract the iron oxide.
No. So okay, so your NaOH is an alkali, and iron oxide they told you is basic. So basic means alkaline as well. Alkali and base are like similar terms. Okay, so iron oxide is basic, and that means it is alkaline, and sodium hydroxide is also alkaline. So they will not react with each other. Okay, what is actually going to happen is that your aluminium oxide, so aluminium oxide is amphoteric. What do we mean by amphoteric? That it can act both. It can act as an acid and it can act as an alkali. So because it has the ability to act as an acid, that is why it is going to react with sodium hydroxide. And what is going to happen? Your sodium hydroxide is going to react with the alkali, and you are going to get a salt plus water. That is what happens whenever you have any acid base reaction, any alkali acid reaction. You always get a salt and you get water, and we will discuss this. Okay, we'll go over this in great detail. This process is known as neutralization. So what is going to happen is this, that the iron oxide is also alkaline, sodium hydroxide is alkaline, so there's going to be no reaction. The aluminium oxide, on the other hand, it can act as both. It can be an acid or an alkali. That's why we're saying it's amphoteric. So it can react with the sodium hydroxide. It will make salt and water, or it's going to get neutralized. You can say that the aluminium oxide will react with the alkali and it will be neutralized. So what's going to happen? That the aluminium oxide will react with the sodium hydroxide and it will turn into a solution. Now the iron oxide, it is not reacting. So the iron oxide is just going to collect like a solid or like a precipitate, or you know how you mix sand and water, so you can see the sand collecting. Just like that, the aluminium oxide will react with sodium hydroxide to give you a solution. It will be neutralization. Iron oxide cannot react with sodium hydroxide because both of them are alkaline. So the iron oxide is simply going to, collect at the bottom, and then you can simply go ahead and remove all of it. Just like use a filter paper, pour it over filter paper, separate the two of them. So that is how, so when I told you at the very start about aluminum oxide, I said step number 1, we have to treat it with sodium hydroxide so we can get aluminum oxide. So that is how you get it.
Okay, yeah, it makes sense.
Yeah, okay. So let's just stop it over here for today. So in the next class, we are going to